Okay, so now we are going to try vacuum forming. You can do it by putting a heater right above the plastic, or you can heat the plastic in an oven and quickly move it over. We are trying to do it with Lexan, which is actually a very difficult material for vacuum forming because it doesn't soften easily, but that's all that I have on hand. So okay, you can go on. Yeah, that's it. Okay, then you can chop it off. As I said, Lexan doesn't really soften, and as soon as it cools down a little bit, it becomes hard, so it wouldn't pull down all the way, but any other plastic like PVC, ABS, polyethylene, they all form beautifully, they all pull down all the way. So for the vacuum forming, all what you need is, still a bit hot, but for the vacuum forming, all what you need, it looks terrible, but anyway, it shows the principle. So you need a bottom mold, okay, and the vacuum will actually spread around. So you don't need to make grooves or anything. The vacuum will spread around the corners. You need a top frame to clamp the plastic, okay, otherwise it will just pull in, the ends will pull in. It wouldn't, okay, and then you need a heated sheet of plastic, and that's it. It just takes 1 second, let it cool down. The advantage of Lexan, of course, it's strong, but it's shatterproof. So, and you have to leave it, for normal plastics, you have to leave it completely to cool down because, you know, it still can distort if you take it out of the mold. The Lexan, it's very hot still, but it's already hard. But normal plastic stays soft a long time. So it will form beautifully, but you have to leave it to cool down. Okay, another process which is sometimes useful is replication of parts in plastic. Now, today a lot of the plastic parts of special shape can be made by desktop printers, by 3D printers, desktop 3D printers, but sometimes you still need a part with a very good finish or with very good properties of plastic, like a filled plastic, which cannot be used in 3D printers. So the way you make it is you make a mold of silicone rubber, and then you pour any plastic you want, including some molten metal too if you want, into the silicone rubber mold. So let's say we have this knob, just as an example, and we want to make a copy of it. So what we do is we put the knob in a little box and cover it with a silicone rubber. This is not the silicone rubber adhesive I showed you in the caulking gun. This is silicone rubber mold making material, which actually doesn't stick to anything. That's its uniqueness. It doesn't stick to anything, so you don't have to put any kind of mold release or anything. So you just put it at the bottom of a little cup, mix the two components, mold making silicone rubber, and over it, and cure it, and you get a part like this. So basically this came out from this. Okay, this is how it came out from the mold, and it pulled out. Because it's so flexible, undercuts are okay. For example, you can see 2 pins sticking inside, and these 2 pins are actually the 2 holes for the set screws. So it's no problem at all to mold it, including the holes, because it'll pull out and release themselves. So you can even see this has Allen screws. You can even see the hex inside the screw copied here. By the way, the ability of this process to copy goes down to a molecular level. Like if you trace the surface here with a probe with molecular resolution, and you trace the surface of the copy, they follow within molecular resolution. The reason I know that for sure, because think of replication of records. Like a normal LP record of the old days had something like a 50 micron groove depth, but near 100 dB dynamic range, which means that the modulation was at the nanometer level, at the bottom, for 100 dB below 50 micron. Okay. So anyway, so it's a perfect process. It is not so good dimensionally, because this can distort. It's flexible, so if you want it dimensionally more accurate, you have to put some metal screen inside before you pour the rubber to just make it a bit stronger. But it's very, very good for surface texture and every little detail. Now, one other thing, when you mix viscous materials like some epoxies or silicone, there's a lot of air bubbles trapped in it. So what you have to do, you have to mix it per instructions, put it in a vacuum chamber like this, and degas it. Degas it means you start up the vacuum, say, and you leave it there for half an hour until all air bubbles exploded. And you have to put in a container much taller than this is because it will foam up, at least 3-4 times taller. So let's say I degas the rubber, put this in a plate, poured the rubber over it, heated it up or waited a day, took it out, and now I have a mold. So now I want to cast a copy of this. So the best way to cast a very high quality copy without air bubbles or defects is cast it in vacuum again by sucking in the epoxy. So the way you do it, you put the mold here inside, put the mold inside the vacuum chamber, you mix up the resin you want to cast, either polyester or epoxy or polyurethane or typically any two-component resin which will polymerize. If you want the best result, you have to degas this first as well. So you only put in less than a third of the height, put it in the vacuum chamber, and first you have to degas the resin itself, so there will be no trapped air bubbles. So you put it under vacuum, you can see the vacuum going up. You wait for full vacuum, bubbles will start forming. Okay, so you leave it there for half an hour until the bubbles collapsed. Take it out. Now you have degassed resin, and the same thing as you did before, degassed silicone rubber. Now you put a feed tube in, and with a rubber plug, one end of the feed tube goes in the resin. I don't know if you can see it here. This is the resin with the feed tube. Okay. Other end of the feed tube goes into the mold. Now it's a good idea because sometimes you can overflow or suck in a bit too much. It's a good idea to put a guard around the mold so if it overflows it doesn't mess up the oven. Just put in a guard like this. Put the other end of the tube in the mold. And now it can be a bit higher because there is a guard there. Like this. Okay. Now as you start the vacuum, it will suck out the material, fill the mold. So you do that, okay, the mold is already full. You can see it sucked out the liquid from here. Okay, now you pinch off the tube because you don't want any more resin inside. Now you release the vacuum. You can see some bubbling there, and you release the vacuum. Okay. Okay, some material sprayed out. Now once you release the vacuum, two good things happen, okay? Even if the material is degassed, there is some miniature air bubbles were introduced by sucking it in and putting it in. Now these air bubbles may have been trapped still inside, but once you release the vacuum, these bubbles collapse because these bubbles inside have very little air because it was all done under vacuum. So even if there were bubbles introduced and what you saw at the end, the foam which was formed, it will all collapse and disappear. So now what you do is you can take out the feed tube, turn on the heater, and depending on the resin you use, you cure it anywhere from 50 degrees to 80 degrees. If it was silicone poured in, I would cure it at 100 degrees. But somewhere in this range, it will cure it in an hour. It will be cured. So silicone will take a bit longer. Now, once you take it out, and of course you can dye the resin to have any color you want. So in this case, I added black pigment to the resin. So I made a replica of this knob. The surface finish on the replica the gloss isn't as high as the original, but a lot of it has to do with this resin because it was crudely mixed and filled, just to show the principle. Okay, so this is a simple process of replication. You can also make two-part molds if there were features on the back of this that I also wanted to copy. What I would do, I would pour another layer of silicone to make the second part of the mold, and I would put in some registration pins. So when I pull it apart, I have two halves of a mold and pins to align them. So I can put it in. I would put a feed hole and an air escape hole or an air inlet hole, and I would fill the whole mold, which will be enclosed, and open it up, take out the part. Now this process works from tiny parts to huge parts, but of course gets expensive because the material is expensive. You can, you can put metal inserts in the mold if you want threads. You can put filler in the mold, like carbon fiber. You can mix the filler if it's chopped finely into the resin, or you can lay carbon fiber inside the mold and impregnate it this way. This is also the process you impregnate electrical coils or other things which have to be waterproof and very durable, because usually air will be trapped everywhere. So the only way to impregnate something with resin is through a vacuum process like this. Now, a very interesting property of silicone is that short term it can take very high temperature. So if you made this mold, especially if you made it from red silicone, which is higher temperature, you can easily melt zinc alloy parts and pour the molten metal into that. You can, even some aluminum alloys can be poured into it once or twice, but it ruins the mold. If you use it for plastic, you can make hundreds of parts with one mold. If you use it for metal, maybe you can make 10 parts. But there is a common zinc aluminum alloy used for die casting, and you can cast parts in the silicone from this alloy, and they look perfect, just like die cast parts.